Welcome to the tutorial on installing and using Nuclear I/O to visualize and annotate your own host-like pathology images. This tutorial is run on a Ubuntu 2004 Linux computer. The prerequisites are to set up Anaconda and Git large file system. Step 1. Clone the GitHub repository. There are few experimental slides stored with the Git large file system, so the Git clone process may take a few minutes depending on your internet speed. Step 2. After you clone the GitHub repository, create a new Anaconda environment called Nuclear I/O. The Anaconda environment helps us manage the Python packages. Next, use Conda to activate the environment Nuclear I/O. You may want to further install OpenSlide and OpenSlide Python to run this program. Step 3. Install the Nuclear I/O Python dependencies. This may take a few minutes to finish. Now, you can either start using Nuclear I/O or watch the optional tutorial on how to pre-process your new host-like images. Optional Step 4. Download the example images. Create a folder and use the command below to download the images. All these commands are from the GitHub tutorial. Optional Step 5. Run the pre-process pipeline. The pre-process pipeline has 3 stages. The first stage is to segment the nuclei. We adopted Stardist for nuclei segmentation. Depending on how large your host-like image is, the first stage can take a few minutes or up to an hour. Here, let's simply speed up the process. After obtaining the nuclei segmentation result, the second stage is morphological feature extraction. This step helps us calculate Nuclear I/O feature that can be used for machine learning classifier. This stage has 3 steps. Step 1. Get the mask of the image. Step 2. Run the nuclei statistics calculation function. This step, depending on how many nuclei we extracted, may take a couple more minutes. In our example, we have 250,000 nuclei, which will take 5.5 minutes. Step 3. Get the spatial features of each nucleus. This step may also take a few minutes. So the last stage is to further extract deep learning features to improve the machine learning performances. There are 32 deep learning features we can extract, which were calculated based on a convolutional neural network pre-trained on the PanNuc dataset. After all these optional steps are accomplished, you will notice a Stardist results folder at the same level as your host-like SVS image. Open it up, and you will see all nuclei segmentation results, as well as pre-calculated features. Now, the last step is to open nuclei.io and analyze your own host-like image. Simply run python software/main.py, and the software will open. You can either choose the case you just pre-processed or open the case in our experimental data folder. Double-click and open the file. Create a new class, tumor, and then start annotating the host-like image. By annotating a few positive cells and a few negative cells, the software can rapidly produce a machine learning model, which can then predict the rest of the nuclei in the entire host-like image. When you open another host-like image, this model can also be used to predict other slides. Here you will see that lymphocytes and germinal center cells were misclassified as tumors. So the beauty of nuclei.io is that you can observe such errors or misclassifications in real time and adjust them through additional annotations. Then the model will get improved over the iterations. This is a typical example of what is so-called active learning. Thank you for watching the tutorial. Please enjoy nuclei.io.